Section 2.1, Solving Linear Equations. We're going to begin by writing some steps that may help us throughout this process. The first step is to clear fractions by finding a common denominator and multiplying by each term. Our second step we'll check is to clear parentheses by distributing. Next, we'll simplify each side of the equation by combining like terms. Then we will move variables to one side and constant terms to the other by using inverse operations. The inverse of addition is subtraction, and the inverse of subtraction is addition. It's kind of like undoing each other. And the last step is divide by the coefficient of the variable. That's if there's one that exists. Sometimes there's not. So moving on, the first thing we're going to do before we actually get into the solving equation process itself is we're going to determine whether 5 is a solution of a given equation. In this, they're asking us to plug this 5 in everywhere that there's an x. So we're going to substitute a 5 everywhere there's an x in the equation, or a variable. It doesn't necessarily have to be an x. Everything else is brought down exactly the same. And now we simplify the left side. 2 times 5 is 10. Bring down minus 3. And 5 plus 3 is 8. 10 minus 3 is 7. This is a false statement. And since this is a false statement, we would say 5 is not a solution to this given equation. Now we're going to move on to solving equations. First thing we want to do is we want to move all the constant terms to one side and all the variables to the other. So using inverse operations, we would like to move that 5 over, so the inverse of a plus 5 is going to be minus 5 or subtract 5. Whatever you do to one side of the equation, you must do to the other. Simplify, you have 2x and carry down what's left, and then 9 minus 5 is 4. Our next step is if there's a coefficient in front of the variable, we're going to divide both sides by that. So if they multiply by 2, we're going to do the inverse and divide both sides by 2. Remember, our goal is to get the variable by itself. So now we're left with x equals 2. This is our solution. It's also can be written in braces as well. Okay, we're going to get increasingly more difficult as we go. We're going to take one step at a time. I want to simplify the left-hand side of my equation and my right-hand side of my equation. I need to do everything I can to simplify it. So I want to see if I can add like terms on the left. Negative 4x and a positive 5x are like terms. So when I combine those, I get 1x. And then I bring down the minus 1 from above. On my right-hand side, 9x and negative 7x are like terms, so when I combine them, I'm going to have 2x, and I carry down plus 3. Now I'm looking at a simplified equation, and I have variables on both sides. When I have variables on both sides, I want to combine them. I usually start with the smaller variable, 1x, and do the opposite of it, or the inverse, which is subtract 1x. Whatever you do to one side, you must do to the other. Bring down what's left. 2x minus 1x is 1x. Bring down the plus 3. Now we want to move our constant terms all on the same side. So I want to move that 3 over by doing the inverse of it. Whatever you do to one side, you must do to the other. Simplify and add down. 1x is just x, so I'm going to write it like that, and that side cancels. So therefore we get negative 4 equals to x, which is the same thing as x equals negative 4, or if it was given in a brackets, it would look like that. Our final problem for today is going to be number 4, which is 3x minus 3 equals 5x minus 9. Now, first thing we need to do is get rid of those parentheses by distributing. So we're going to have 3x. 3 times a negative 3 is a negative 9. And this right-hand side we just carry down. Now, we need to move all the variables to one side and all the constants to the other. So I usually start with the smaller variable, 3x, and do the inverse of it. Whatever you do to one side, do to the other. Bring down what's left. Now, I want my constants to be all on the same side, so this negative 9 on the right, I want to move it to the other side by doing the inverse. That means I'm going to add 9. Whatever you do to one side, you must do to the other. Make sure you're always working with the side the variable's on. And over here, this also zeroes out. You have to have 0 as a placeholder, and as you continue to carry the rest of it down, you have 0 equals 2x. We're still trying to get x by itself, so if they multiply by 2, we're going to do the inverse and divide both sides by 2. Whatever you do to one side, do to the other. And 0 divided by 2 is 0. Or can be written as x equals 0. Now, we didn't explain how we can check our solution in any of these, but if we go back to, let's say, problem number 2, and I want to check my work before I submit it on a test. I can check my work by taking the original problem, 2x plus 5 equals 9, and substituting the solution in for x. So if I substitute 2 in there, I'm going to have this. 2 times 2 is 4. 4 plus 5 is 9 equals 9. This is true, therefore it checks, and I know that my solution is correct. I can do those for all of the examples that I work for solving equations.